Welcome to the first video in a series of videos that are intended to show us, in a nutshell, how we can model better and more efficiently and more robustly. And I'm going to show us how to do this in PowerPivot and therefore Power BI. If you know PowerPivot, you know Power BI and vice versa for the most part. So I want to start off by saying what this video series is not. This is not a series on Power BI reports and how to make it look good. In fact, I need some help on that. So any comments, leave them below on how to make these look good. This is also not a demo on Power BI in general. This is for a specific purpose of building models faster and more efficiently. I'm an amateur. I'm a beginner with this. I've taught myself this modeling principle and a little bit of data architecture over the last few years in order to more quickly and more efficiently model scenarios and model variances and model lots of things, actually. I'm leaving this blank Excel spreadsheet up here on purpose. To a finance person, this is a thing of beauty. But again, let's go back to the point. I like to know that I'm modeling faster and easier. And this is going to be a video series on how to do that. It's a very practical training. It's not going to be a super deep dive. I know there will be plenty of people who watch this that say, you should do this better this way. And if that's the case, I want to know again in the comments below. But this is from a very practical standpoint, from someone that just wants to learn how to model better, more efficiently, easier, that's less prone to errors. I want that. I want to free up time for me to do other types of analysis for, in this case, I'm in finance with my business partners, but it can be for anybody you're doing an analysis for. So to kind of give you an idea of how this series is going to go, I'm going to first introduce some problems we generally see when we are trying to model and trying to compare, in particular, two data sets. And I'm going to go through some of the problems and then some of the solutions that I've used. Again, may not be the best, but it's helped me, and I think it will help a lot of folks who watch this. But let's just jump right into it. So we've all made a forecast before, and your forecast can be down to any granular level that you have, down to potentially even a SKU or even a city, or that is completely arbitrary and up to how your business collects data. But for the sake of this exercise and throughout this series, we're going to have a specific set of data points. We're going to go from right to left here. We have an order number. We have the region. We have a country placeholder that is going to come in later, a country, a product number, the product that's associated with that product number, the quantity purchased, the date that it's going to be purchased, the customer number, the customer that's associated with that customer number, and obviously the revenue, which is just your quantity times the price, but you notice that that's not in here. We'll get there later. So if you're looking at just your forecast in general, it's easy enough to throw that thing in a pivot table and to get some level of intelligence around it. You say, okay, I want to see what's the geography forecast going to look like. So if we want to look at what our revenue is going to be, I always like to put it in currency. So, okay, so for the year, this is what the breakout is for each region. Well, how's that going to break up for the months? Okay, so we can kind of see that. And then we can also say, well, I wonder what that's going to be. What are we forecasting for customers? Maybe you've got a certain salesperson that is in charge of Bass Pro Shops. I should say that all of this data is completely made up. Some things I just made up for fun. Some things like Bass Pro Shops is a real shop, but this is all just completely made up. So you can get some level of intelligence here by what you currently have in your one single data set. If you wanted to look at the country that all these are going to go in, you can see that too. So this is a forecast that is made by whoever at your company. So that's all great. manipulate this piece of data as much as you want. You can add different columns in here if you want. If you learn later that this customer is in, whatever vertical, you can add that. But, suffice it to say, you can manipulate this data set as much as you want in this pivot table or maybe other ways. But let's jump forward a little bit where we have actuals. So we see our actuals come in, and then we want to know, well, how does this compare to our forecast? A very common thing. You want to look at your actuals versus your budget or your forecast. Other common comparison points, if you will, are if you want to do two different scenarios. If you want to plan for 20% growth in your sales compared to 20% decline in your sales, what will that do to margin? Or any number of comparison points where you need to compare two data sets is where this would come in handy. So when you want to compare your forecast to your actuals, I have another sheet open here. We'll call this forecast actuals. Similarly, you could throw this into a pivot table. Do the same type of thing where you bring revenue in. Let's convert that to dollars, and then we'll bring the date in here. Looks like we have, several years of actuals in here. And then you say, okay, I want to bring in the regions. I want to see what the regions are like compared to my forecast. Let's say we're at the end of the year. You can do this at any point in the year, but say at the end of the year we have full 2020 actuals. But then you see, okay, let's compare 2020, let's take out the quarter. Let's just look at the month. Oh, and there's Americas, but then there's AMS. Like, what? Oh, then you realize, okay, in a lot of places when actuals come in, sometimes it's not as clean of a data. The data is not as clean. So while you forecasted for just Americas and EMEA, for example, these three different buckets, what you get in actuals is not as clean. So you can say, oh, well, that's okay. Let me just do some analysis. Let me just do some consolidation here. So for the Americas, I'm just going to say that's the sum of these two here. Okay, perfect. And then, EMEA, that's just the sum of these two here. Okay, so, let's move that over here. And so, yeah, let's move that here. So, okay, now let's just drag that across, and then we can maybe see, in the worst case scenario, we could just say, okay, let's just flip back and forth. So we had, for actuals, we had $40,000 in revenue, but we forecasted for 74. Okay, so that's not too, we're that's not good. It's not good. For EMEA, we forecasted 409, we got 64. Man, what's going on? Or, maybe to be a bit more, and so we don't have to flip back and forth, because that's the worst case scenario. We could do something like a VLOOKUP, where we just do, VLOOKUP. Let's look at EMEA, and then let's say, since that's like that, do 2. Oh, actually, no, wait a minute. We got to go all the way to the end. So let's go N, and then do 2, and then 0. Okay, so we could do it that way. Again, doing some VLOOKUPs to try to make it a bit quicker. And obviously, I'm painting a worse picture than maybe most of us are in. But a lot of times we will use these discrete data sets and compare these discrete data sets that are not inherently linked. So a lot of times, I've seen and we'll see a bunch of different tabs that have all these different data sets. Maybe there's different tables. There's different tables that will say, the different pieces of the different regions. So we'll come up with a number of ways to compare these two data sets. They're discrete data sets. They're not inherently linked. But what I want to show to you is how we can build a model, and again, it's going to be in Power BI or in PowerPivot that will then push to Power BI. How can we build a model that inherently links these? So we no longer have to deal with missing formulas or hard-coded numbers